All right, welcome everybody to today's video lesson. This is 1.3, solving absolute value equations. All right, so you're going to recall that absolute value is the distance from zero on a number line, okay? And we know that anything inside those absolute value bars has to come out as positive. Okay, but that means that you can plug a positive or a negative inside and still get the same result. Okay, so for this little example here, the absolute value of k equals 8, we have two possibilities for k. We could say that the absolute value of 8 equals 8, and we could also say that the absolute value of negative 8 equals 8. So just given this equation here, we can't tell any more about whether it was supposed to be a positive or a negative. So we have to account for both options. And that's what we're going to do when we solve these equations. So our variables are going to be inside the absolute value bars. So we're not going to know if we're plugging in a positive or a negative because both of those options will come out to the same result when you evaluate the absolute value bars. Okay, so you want to take a second and pause your video right here and copy down your steps for solving. Okay, so the first step is that you want to isolate the absolute value bars. So we want to use our steps for solving, which are SADMAP, and we want to move any numbers or operations that are happening outside the absolute value bars. Okay, so we want to have just the bars on one side of the equation and our constant on the other. Okay, we're then going to split this up into two separate equations. So we're accounting for that positive option and that negative option that we were just talking about. At that point in time, when we split these up, this is where we're going to drop the absolute value bars. Okay, because we cannot solve until our expression is out of the bars. All right, and then we're going to make sure that we solve both equations. That's very important. Okay, so you're going to have two answers to every absolute value equation. Very, very important. If we forget half the problem, we've lost half of our points because we didn't get both solutions. Okay, so we're going to start with a very easy example here. So there is nothing outside of these absolute value bars on the left side of the equation. So this expression is already isolated. Means there are no other numbers outside the bars. So now we can split this up and we're going to drop the absolute value bars. So we're going to keep x plus 3. We're going to set it equal to a positive 8. And we're going to take x plus 3 and set it equal to a negative 8. So our answer, okay, in the original equation, the answer is what we change, one with the plus and one with the minus. Okay, the expression inside the bars never changes. It's always x plus 3 no matter what we're doing. All right, and now we can just solve these like normal. So subtract 3. Okay, so our first answer is 5. And our second answer is negative 11. Okay, don't just assume if the first answer is 5 that the second is going to be negative 5. That's not how this works. All right, so let's look, and always remember, before we go on, we can always check, just like we do in regular equations. So you can take your two answers and plug them back in, making sure you get the same outcome. Okay, all right, so now let's take a look at one that's got something else going on outside. Okay, so we can see on the left side of the equation here that the bars are not isolated. We need to get rid of the 3. So what operation is the 3 doing? It's currently multiplying, which means to move it to the other side, we would use division. Okay, so we're going to divide out that 3. Still inside the bars here because we have not split up. Okay, but now the absolute value is totally isolated. We can split it up and drop the bars. So x minus 5 stays the same. We get one positive answer and one negative answer. Okay, and now 2 very simple equations that we can solve. Okay, remember, always show all of your steps for solving. Okay, add 5 to both sides. And I have 2 solutions for this absolute value equation. All right, so a number in the front, we would divide that out before we try and split our equations. All right, let's see some more. Okay, so this one has 2 operations. There's a minus 3 on the end and there's a 5 in front. So if we remember to follow SADMEP, okay, we follow our steps for solving when we isolate. So subtraction and addition comes first, which means I'm going to add 3 as my first, I'm going to add 3 as my first isolation step. Okay, now the 5 is being multiplied like we saw in the last example. So our second step would be to divide. Okay, it keeps jumping on me, doesn't like this example. All right, so we see that these bars are by themselves, so we can isolate, or we can split up, sorry. So four x minus 7 equals 3. 4x minus 7 equals negative 3. Okay, so we see in this first solution here, 10 is not going to divide evenly. That's fine. We're just going to leave it as an improper fraction. We're going to make sure that we reduce. Okay, so this would be 5 over 2. Because this does divide nicely, if you wanted to say 2.5, you could. But in situations where it doesn't divide nice, you would want to leave it as the improper fraction. All right, and then let's not forget to solve our second one. Okay, and we have our second answer. All right, so this was a 2-step isolation process, add 3 and then divide by 5. So we're following SADMEP order, which is order of operations in reverse, when we go to isolate. And it's only after we isolate, which is right here, that we drop the bars. All right, let's continue. Only a couple more left. All right, so this is always a tricky setup when we have two numbers in front of the bars, or even like when we were solving regular equations, we had them in front of the parenthesis. So we have to identify the operations and make sure that we are performing the correct opposite operation in order to isolate. So we're not actually doing 5 minus 8 because the negative 8 is really multiplying to the absolute value bars. So in following SADMEP, okay, we should actually subtract 5 as our first step. Okay, and now we can divide by our negative 8. Okay, so my bars are isolated. And I'm going to go ahead and split into two equations. So one that is positive and one that is a negative answer. All right, this one is very easy solving. Get x equals 5, x equals negative 5. All right, so just pay attention when you get something like 5 minus 8 in front. Make sure you're identifying what operation is each number doing. All right, so the 5 is really adding and the 8 is multiplying. And then you want to follow SADMEP order. All right, last thing for today are two special cases. All right, so if I were to try to solve these using my isolate, split, and solve, okay, looking at example A, there's nothing to isolate, okay, because the bars are already by themselves. So I would go into split. Would I say x plus 1 equals 0 and x plus 1 equals negative 0? That doesn't really seem right, okay, because 0 can't be negative. So I'm not really sure what that's going to mean. And my second example here, example B, think for a second, pause your video. Do you see anything wrong with that example? See anything out of place? Okay, so if you came up with, well, it's equal to a negative, which doesn't make sense because anything that comes out of the bars okay, when we evaluate absolute value, has to come out of the bars as what? Has to be positive. So how is something coming out of the absolute value bars and it's negative? Okay, so what does this mean? What are my two special cases? Okay, so this is how we get one solution. Okay, anytime that the absolute value bars are equal to 0, we're only going to have one solution because that means there's only going to be one equation because 0 cannot be negative. So we wouldn't even have to split case 1. Okay, and then case number 2, anytime you're isolated absolute value bars. So this is important. Let's make a note here. Okay, we have our absolute value bars equal to a negative number. That gives us a no solution. That's not possible because we cannot evaluate absolute value and get a negative. But the bars must be isolated first in order for that to happen. So here's a quick little example. Okay, so if I was looking at this equation, I would not want to classify this as no solution just yet. Even though there's a negative on the right side of the equation, when I isolate the bars by dividing by -2, I'm actually looking at the absolute value of x equals 10, and there's nothing wrong with that situation. Okay, so we don't want to make this decision for case number 2 until the bars are isolated. All right, but if you have something like absolute value of 2x plus 3, equals negative 15, that for sure is no solution. Okay, because on the left side, the bars are by themselves, meaning there's nothing on the outside, front or back, and the equation is equal to a negative number. All right, so those are all of our notes for 1.3 absolute value equations. So make sure that you have everything written down before you complete your video. Write down any notes that you have for class, and I will see you next time.